The end of chapter 21 is about the power of a test. They'll ask about power very often when they ask about errors. So it kind of goes hand in hand. There's going to be a lot of things that we could conclude after I finish this chapter today. But instead of writing down a bunch of statements to be memorized, you're going to have to memorize how they're all related so that you can figure it out. There's no reason to memorize a bunch of statements in this case. So you can't ever prove that a null hypothesis is true. You can't do it, right? We don't know. We might fail to reject, but it doesn't mean that the null hypothesis is actually what it's supposed to be. We can only fail to reject it, and when we fail to reject a null hypothesis, it's natural to wonder whether we looked hard enough. If you failed to reject and you thought there was some change, well, then did you do something wrong? Could you have done something better in your survey? It's just easy to wonder about what's happening. So might the null hypothesis actually be false and our test too weak to tell? So when the null hypothesis is actually false, that's the key point of this. The null hypothesis is actually false. We hope our test is strong enough to reject it. So we'd like to know how likely we are to succeed, and the power of the test gives us a way to think about that. So by definition, the power of a test is the probability that it correctly rejects a false null hypothesis. That's making a correct conclusion, again, only when the null hypothesis is false. So pretty much paraphrase, probability that you make the correct conclusion. But we're only talking about the null hypothesis is false. If the null hypothesis is false, we want to reject H naught. And the power of the test is the probability that's going to happen. They won't ever ask you for the actual probability. That's not what we're going for here. We're just talking about kind of in general what power is. They're not going to say, what is the power? They're going to say, what does the power mean in the context of this question? Okay? So when the power is high, we can be confident that we've looked hard enough, we've made the right conclusion. So when the power is low, maybe we have more questions and doubts. We know that B is the probability, or beta is the probability, that a test fails to reject a false null hypothesis. That's a type 2 error, right? False null hypothesis, you fail to reject. Well, if you have a false null hypothesis and you fail to reject a type 2 error, and the probability of that is beta, then the opposite, the probability of a false null hypothesis, but you reject it, has to be the complement, has to be 1 minus beta. Those are directly related. They are direct complements of each other. So if you increase for some reason or by accident or whatever, you increase the probability of a type 2 error, then you decrease the power. If you decrease the probability of a type 2 error, you increase the power. Right? They're directly related. If you change one, the other one changes. Okay? So here's an example. Kind of talked about some of this yesterday. A study of Avandia, which is a drug, combined results from 47 different trials, a method called meta-analysis. The drug's manufacturer, GSK, issued a statement that pointed out each study is designed differently and looks at unique questions. For example, individual studies vary in size and length, and the type of patients who participated, and then the outcomes they investigate. Nevertheless, by combining data from many studies, meta-analyses can achieve a much larger sample size. Right? What did we say about larger sample sizes yesterday? Right, if you increase the sample size, that's the way to reduce type 1 and type 2 errors at the same time, right? Because the larger your sample gets, the closer your mean of your model gets closer to P, the true proportion, right? So if we increase the sample size in this case, we've reduced the probability of a type 2 error. And if we reduce the probability of a type 2 error, what's happened to the power? Right, we've increased the probability, we increase the power. Remember the direct complements. If you decrease one, you increase the other. Okay? So in this case, in their answer, if Avandia really did increase the 7-year heart attack rate, doctors needed to know. To overlook that would have been a type 2 error, failing to detect a false null hypothesis, resulting in patients being put at greater risk. So increasing the sample size could increase the power of the analysis. making it more likely that researchers will detect the danger if there is one. Right? Again, the power is the probability of correctly making a decision if the null hypothesis is false. Okay? When we calculate the power, we imagine that the null hypothesis is false. That's the whole point. So the value of the power depends on how far the truth lies from the null hypothesis. So we're saying the null hypothesis is false. So when we say P equals something, in the case of the power, we know that's not true. Right? So it would be nice to be able to compare them. So we call the distance between the null hypothesis value, P naught, and the truth, the effect size. The larger the effect size, so the larger the gap between the actual P and what we claimed it was in our null hypothesis, the easier it is to detect what's wrong or to reject the null hypothesis, right? The larger it is, the larger that gap, the easier it's going to be. So the larger the effect size, also the larger the power. Okay? Maybe. The larger the effect size, the bigger the difference between our null hypothesis value and what P actually is in real life, the easier it should be to detect and reject the null hypothesis. If they're really close together, it's hard to find a p-value that's going to be rejected, right? They're farther apart. When you do the z-score, you'll get a larger z-score. I don't know. Ken doesn't like them. Okay. Doesn't depend on anything. Just if the effect size is larger, the power is greater. This is an image you need to put into your mind, and this is how you're going to remember how everything is related. This image. Okay? I don't care if you really understand, this is awful of a teacher to say, but I don't care if you really understand what is all going on. I just want you, if you can visualize this picture, you should be okay in figuring out answers to questions. Okay? It makes intuitive sense that the larger the effect size, the easier it should be to see it, some difference. And obtaining a larger sample size decreases the probability of a type 2 error, so it increases the power. We talked about that too. It also makes sense that the more we're willing to accept a type 1 error, the less likely it will be to make a type 2 error. We talked about that yesterday too, right? Type 1 and type 2 aren't complements of each other. Those probabilities aren't related. But if you decrease type 1, you increase type 2 inadvertently. If you decrease type 2, you increase type 1 inadvertently, right? There's always that battle between them, okay? So we have this line, because they're going to ask you all sorts of questions today. We know alpha is the probability of a type 1 error. We know beta is the probability of a type 2 error, right? So let's talk about some things that could happen. This is the type of stuff they're going to ask you. Let's say I increase my alpha level, okay? If I increase my alpha level, so increase my alpha level, so now my alpha level is all this part shaded in, right? Yeah. Then what's happened to the type 2 error, the beta level? It's gotten smaller. And so then what's happened to the power? It's gotten bigger, right? So you've increased alpha, you decrease beta, and increase the power, right? They're going to ask you all these questions all together, so you have to be able to visualize, okay, what changes, what other thing changes. That's why I was saying I could give you all these sentences you have to write down, but that doesn't help you see it or understand it. Okay? So then let's say if we do the opposite direction. If I move this critical value over here, right? I have now decreased type 1 error probability, right? But I have increased type 2, and so I have decreased the power. What's the top one? You're decreasing type 1 error. No. So power and type 1 are not related. Remember, power all has to do with the null hypothesis being false. You only get a type 1 error when the null hypothesis is true. Right? That's why type 2 and power are so directly related, because they both are based on when the null hypothesis is false. Okay? But so if you have this picture in mind, right? Then, okay, and really if you don't even have that picture, but if you're just thinking about it, okay, we know type 1 and type 2 are in this like battle, right? They're not complements, but they're in this like war with each other. So if one moves forward, the other one's backwards, right? So if you know the power is related to type 2, right? If you know what happens to type 1, then you should know what happens to type 2, then you should know what happens to the power. It's like this domino thing. All right, so when they ask you all these questions, it's not really trick questions, and it's not the stuff you have to like really memorize as long as you know that how these things fall. All right, and I think it's easy to understand type 1 and type 2 go back and forth. So if you can remember that, then you should know power goes back and forth. Okay, with me? Okay. Now, so far we've talked about, and we talked about this a little bit yesterday, but we've talked about if you increase type 1, you decrease type 2, right? And if you increase type 2, you decrease type 1, all that jazz. What if I want to decrease the probability of both of them, type 1 and type 2? Bigger sample size is the only way to accomplish that, right? Because if you look at this picture, then look at my next picture. Same picture, but they're narrower, right? Your bell curve is taller, right? It's closer to P, so yes. So you have a greater sample size, so it's closer to that normal model, right? And if you have a larger sample size, you're closer to what P is supposed to be anyway. So if you decrease both of them at the same time, that is literally the only way to decrease both of them at the same time. Right. If you increase the sample size, then you should increase your power because it should get closer to P, right? And so you have more confidence in making a decision. So yes, it increases the power as well. Okay? Are these things making a little bit of sense? We're going to do a question in context. And I'm not writing. See, I thought this through already because the pen sucks. So I scanned in my answer so I can just click through. But genius. All right, here's the question. A company is sued for job discrimination because only 19% of the newly hired candidates were minorities, when 27% of all applicants were minorities. That sounds like an HR nightmare, right? Is this strong evidence that the company's hiring practices are discriminatory? Now it's going to ask you all these questions. You can see in there it has like in context with type 1, type 2, stuff we've been doing. So it doesn't ask you anywhere for hypotheses, but it's going to be almost impossible to write those unless you write hypotheses down somewhere, right? So it doesn't ask for it, but you should write some hypotheses in words, right? That's what's going to be asking about anyway, words, not numbers. So again, whatever the claim is your alternative, and whatever the opposite is your null. So they are claiming, they want to know if there's strong evidence that the company's hiring practices are discriminatory. So my null hypothesis is not discriminating. Alternative is they are. Right? Okay. So, part A. Is this a one-tailed or a two-tailed test, and why? So if you were going to do this in numbers, so they do give us the numbers, right? We would know if P equals, or if P is, we want to see if P is less than, right? For alternative. So we want a one-tailed test. Yes? If you're going to explain it in context, we want to see if it's less than, because if it's less than, we're going to get sued. Right? If it's greater than, no one's going to care. But if it's less than, we're going to get sued. Right? So, I totally get it. No big deal. But we understand why it's a one-tailed test. Yeah, two-tailed would be not equal to. I wrote, oh, it's still on this page. One-tailed test, the company would not be sued if they had a lot of minorities. That's how many, there's 27% that applied, and you had around 27%, it'd be fine. So far, so good? Part B and C, naming errors, type 1 and then type 2. So again, type 1, the null hypothesis is true, right? But we do what? We reject. So the null hypothesis was not discriminating, right? So, yeah, so the null hypothesis is true, but we reject. So we think they are discriminating, but they really aren't. Right? That's what a type 1 error is. The null hypothesis is true, but we conclude otherwise. So I wrote company is not discriminating, but with someone, a court, somebody thinks that they are. Everyone go with that. The next one was a type 2. Null hypothesis is false, but we failed to reject. So null hypothesis is false, then they are discriminating, but then somebody decides that they aren't. Someone concludes that they aren't. Right? Yes? Right? We did that yesterday. I think we're getting comfortable with that. All right, then. Part D. In this context, what is meant by the power of the test? So not what is the number, because we don't need to care. We don't need to care about that. What is meant by it? So remember, the power of a test is correctly rejecting a false null hypothesis. So correctly concluding that they are discriminating when they really are discriminating. Okay. All right, and that's all I wrote. Yes. I don't know if I put this on. The power of the test is the probability of concluding that the company is discriminating when they really are discriminating. Yes, but if you put it in context. Correctly rejecting a false null hypothesis. I'm sorry, I'm in your way today. Awful. Yeah, so it's not asking for a number, it's just asking you to write it out in context. Making the correct conclusion. No. Yeah, if they aren't discriminating, they're not. That's not anything. All right. So let's talk through some of these. And there's 2 more questions. So if the hypothesis is tested at the 5% level of significance instead of 1%, how will this affect the power of the test? So it was originally being tested at 1%. That's a percent of what? Which error? Type 1 error. Oh, okay. A, type 1, same thing. Alpha is the 1%, so it's a type 1 error. So if it was at 1%, and then we're now going to test it at the 5%, what have we done to the probability of a type 1 error? Increase type 1. So what has happened to type 2? It's decreased. So what happens to the power? It increased. So the power of the test has increased. No, just increase the power of the test. Right? Yeah. Super fancy. The next question, I want to go back. The next question says, this test was done based on 37 employees. All right? 37 employees. How would that compare to a test with 87 employees? If you increase the sample size, what happens? Both the errors go down. What happens to the power? It increases, right? So the power increases. So the power of a test for 87 people would be greater than the power of a test for 37 people. I don't remember how the question was worded, but I think I said something along those lines. The power of the test wasn't really good context. This was last year. The power of the test for 37 people is lower than a test based on 87 people. That's how the question was wanting you to answer. Okay? But does that make sense? I have no idea if the conditions are met or not. It's a good question. Question. Okay, then.